I actually remembered to record. We're good to go. So, whether you realize it or not, we've only done derivatives on equations that were considered explicit, and we would have never used that word explicit before. Explicit means that it's solved for a variable, like y equals or f of x equals. Those are explicit functions. And I mean, it's basically like literally like half of them. And that's all we've worked on up until now. So implicit differentiation is learning how to find the rate of change of equations that aren't solved for a single variable. And it's not really much different than what we've done before. But what this kind of does is it allows us to find rate of change of equations that aren't functions. So like like a circle, oval, hyperbola, like there's a lot of different kind of equations that aren't functions that you actually end up using for things. And that's kind of where this comes in. And our goal is just to figure out how fast they're changing. So it would have been better if I read through all of this ahead of time. Yeah. So the easiest way to say it for now is virtually everything we're going to do right now, we're going to treat x as the main variable. And anything that's not an x, whether it's a y, whether it's a z, whether it's a t, we're going to treat it as if it's like u substitution, like a u. So derivatives are going to work the same no matter what variable we're working on. And if it's an x, we treat it like regular. Like derivative of x is 1. If it's not an x, like say a y, when you're at the stage where you have to find the derivative of y, we're not going to be able to say it's 1. We're just going to refer to it as y prime. It's the same as saying, like, when we do the chain rule, I wrote that different up there. When we do the chain rule, at the end of the chain rule, it's u prime. And that's because we don't really know what u stands for, but we know that u is based off of x. So that's kind of how implicit differentiation works, and it may not make full sense to you yet, and that's okay. Like, there's nothing wrong with you learning how to do it, and then as you go, it starts to make more sense, and it may take multiple years. Like, don't feel like this is something you have to, like, get right away. There's a lot of students that go through Calc 3, Calc 4, and then they traditionally have a class after Calc that basically looks at all the fundamentals of Calc. And it's not super uncommon for you to know how to do something, but not fully get or understand it at first. And implicit is kind of like one of those things that I feel is in that category. Like, you'll learn how to do it. It may not click for a while, but don't let that discourage you, I guess is my point. The main thing that you're going to look for, no, I need the marker. Is this right here. Something like that notation. So remember how I started off by saying x is considered the main variable? That notation right there is what tells you what's considered the main variable. So when it says d dx, that means we're basing everything off of x. So when you run into an x in derivative terms, then like the derivative of x is 1. Derivative of any other letter, you don't know, so you just write that letter prime or whatever notation stands for it. It's not always going to be x. So that's why I'm presenting it this way. as we move past like how to do derivatives, well, then we're going to start getting into actual, like, I'll call them word problems, but like problems that represent things. And in most of those situations, time is the variable. And so if this would say ddt, or if it tells you to take with respect to time, then t is what you consider your main variable, and everything that's not t, you treat otherwise. But this is kind of, it's very, like, it's notation you would overlook, but it's actually a big deal. Okay, let's just try one together. So we've got xy plus y equals 8. So definitely not explicit because it's got all the variables grouped together. So implicit differentiation, right here when it says find dy dx, the x being on the bottom tells me that that's my main focus. Like x is what everything is based on. So if I have this written out, the way implicit differentiation works is we take the derivative of everything. So we're taking the derivative, so this is the notation that's like the verb, it says to take derivative. So we're taking the derivative of the left-hand side and then taking the derivative of the right-hand side. Now, we did that before, but it just never really felt like it because like it was y equals. And so you did the derivative of the left-hand side of y, but we just wrote y prime. So now I'm going to be doing the derivative of the fact that this is plus means that they're separate terms. We can do the derivative of each term individually. So I'm going to take the derivative of xy, then I'm going to take the derivative of y, and then I'm going to take the derivative of 8. I feel like we can start with 8 because that's the easiest. What's the derivative of 8? 0. Yeah. Now that's the easiest. I can tell you from a student standpoint or from the teacher correcting the test standpoint, that's the thing that everybody forgets. Is when it says equal to a number, a lot of people will just like overlook it and write equal to 8 on the next line, forgetting to do it. Okay, so I need to take the derivative of x times y. How do I approach that? How do I take the derivative of two things multiplied? Product rule, yep. Yeah, power and product, I always say them backwards. But the fact that they're being multiplied means I need to do product rule. They're two different, they're variables. If one of these was a regular number, then we wouldn't need to use product rule, but they're both variables. Okay, so the derivative of xy is going to be first times the derivative of second. So what's the derivative of y? Y prime. Plus second, which is y, times the derivative of the first, which would be the derivative of x, 1. Because x is our focus, we can actually do the derivative of x. Okay, so this is the product rule from xy. Then I'm going to say plus, and I'm going to be doing the derivative of y, y prime. Go ahead and ask away if you're confused on anything I wrote up there. It's easier to ask questions now than to wait till the end.
So when you're taking the derivative of x, it's always going to be 1?
As long as x is the focus.
Yeah, okay.
So if this said d dy, then the derivative of y would be 1. Derivative of x would be x prime. Yep. It's kind of weird because we've never focused on different letters before. So that's why it feels strange doing this for the first time. It's just a tiny section in your packet, but to me this is something we used to take 3-4 days on. So I'm not going to rush it just because it's not much in there. Are we okay with what's here? All right, so the, the notation or the question said find dy dx. Now, I wrote y prime. It's also would have been acceptable if I would have written dy dx instead of y prime, because they mean the same thing. A lot of students just like this prime notation better because it feels less confusing, but it's kind of up to you. So, but if this says find dy dx, it means find y prime. Okay, how do I solve for y prime now? Because it's in two spots. Now this is like algebra skills. I can rewrite it if that helps, but. Do you want me to give you a minute to kind of stare at it and think about it and try to figure it out? You got to get y prime by itself. What would you have done a while ago if you had x in multiple locations? How do you try to get the x by itself if it's in multiple locations?
You divide the x from y.
Seems like you should be able to, but that actually makes it worse. Like if I just divide by x, then I would have to divide everything by x.
Oh.
So yeah, I mean, like the logic seems correct, but it.
Subtract the plane line on the other side and factor out a y prime.
I didn't hear the second thing you said.
Factor out a y prime.
Good, very good. So your goal, if you're trying to solve for something, is to group them together. So it's like when you first started learning solving equations, you brought all the x's together. No, normally there were numbers on them, so you could like add them. But in this case, we don't have numbers, so we can't add them. But the way that you actually add them together is by factoring out y prime. Then this would say x plus 1. If this was a 4y prime and a 5y prime, you would do 4 plus 5 in your head. But since they're different things, we're trying to do x plus 1 in our head, and you can't. That's factoring something out does the same thing as addition. But this is the method you're going to use a lot to solve for something. If you're being asked to solve for something, you're going to group them together, put everything that doesn't include that term on the other side. It doesn't matter how messy the equation comes out. And then factor out what you want, because now we only have a single one of them. And then we divide by whatever was there. Oh, that didn't work. Now, I'm okay with you writing y prime, and I'll probably wait until you're more comfortable with notation. But like on the AP test, if they ask you to find dy dx, you have to find dy dx. You can't find y prime. Like the notation that they ask for in the problem is kind of what they expect you to use. And so as you get more comfortable with it, we'll do better at that. I'm more focused on you learning implicit differentiation now rather than throwing everything at you at once. Are we somewhat okay with this one? Go ahead.
Why do they give you points?
I did not even read that part of the problem. Good question. Very good question. Because I didn't answer the question. I was so focused on teaching you implicit differentiation that I ignored this. We were being asked to find the slope at 3, 2, not just the generic slope. So y prime represents the slope anywhere on this function. And that's what you find with the differentiation. And I flat out did not even read 3, 2. So the difference now, though, is when you're doing implicit differentiation, you're traditionally going to need more than one variable number to plug in. So they're not going to say find the slope at x equals 2, because if it's not a function, you, like, think of a circle. I can't say find the slope at x equals 2 because that could be at multiple spots. So if you're being asked to find the slope on an implicit function, bad wording, an implicit equation, they're generally going to give you 2 numbers. Generally, not saying they always would. So then we would plug in both numbers in here. So y prime at 3, 2 would be negative 2 over 3 plus 1. So negative a half. So whatever that equation looks like, I have no idea what it looks like. The slope at 3, 2 is negative a half. I wonder why it started with points. I guess I didn't even notice that. Normally we're just practicing implicit differentiation first. Whatever. How about the second one? Do you feel like that's like a lot harder? Is that something you feel like you could try on your own? Or not yet? I don't know your comfort level on this yet. Do you want me to help you start it?
Yeah.
Okay, we can do that. Let's start it together, and then, like, I'll do the first step with differentiation with you, and then try to finish it on your own. Okay, so I am going to take d dx of everything. Doesn't really matter how you write it out. I'm just taking the derivative of the whole thing. So first term, derivative of x is 1. Okay, now I'm going to take the derivative of 3xy. So this one's going to be product rule. I'm going to guess you saw that just because it's like the xy from the other one. My question to you, how did you guys view this when you had this question before? Do you like to think of 3x as f and then y as g? Or do you like to think of it as a 3 multiplier and then product rule of xy? I wanted to do it the way you guys would view it. Both are correct. Or did I just throw you off and neither of you knew what I was talking about ahead of time? Okay. Is this confusing what I wrote with the 3?
No.
Oh, okay. So 3x. That's f, that's g. It's kind of like I wrote a face on there. It's like eyebrows. I like that. It's a meh face. Okay, so first, derivative of second, so derivative of y, plus second, derivative of 3x would be 3. Okay, so there's our whole product rule. Now I'm going to go on to the third term, which is 2y squared. Anybody think they know the derivative of that one? Yeah. How come? How come?
Because of the chain rule.
Okay. So the way that you should view this, if it's not an x, is if every single one of these variables is a u. So like in my head, this is 2u squared. So it needs to be chain rule because it's a u. So 4y would be the normal derivative, no matter what the variable is. And then because it's not x, you do the chain rule at the end with y prime. This y prime at the end is going to be the easiest part for most students to forget. Equals 0. See, like, you spend all your brain power on the hard part, and like on a test, when you're so in a hurry to move on, it's really easy to write equals 2. And I always feel bad because it makes the entire problem wrong, like immediately. Okay, I'm going to let you guys try to finish it from there. So that's the derivative.
What is his differentiate, like, what are we trying to find? Like y prime?
Yes. Yeah, differentiate is another word for derivative.
Okay.
Oh, actually, that's a great question. I don't know. I would have never thought of that. My guess is it's probably okay. I think the reason that the donuts usually isn't a great plan is because then it's kind of like all over. It's nobody in this hour.
Okay.
It's fifth hour. And you can't even open it. I think your snack bar is telling you something. So most definitely what I've been noticing this year, I shouldn't even just say this year, but like the first line of the problem is supposed to be the hardest step. The first line is taking the derivative. Like, that's supposed to be the hardest part. And every line past that is supposed to be algebra. But it feels like you guys I sense that the last part of the problem is the hardest part. Now, I'm hoping you're going to get enough practice at these that this won't feel difficult to you. I mean, that's the hard part for me as a teacher. For you to get better at it, you got to try a bunch of them, but they go so slow that... How many of you got 4 on your own before I put it up there? Oh, that's pretty awesome. So this feels okay. This feels pretty good so far. Okay, I'm going to skip basically all of page 2, which I think is just more practice at these. Yep.
Can you explain the 4y and y prime? So it's basically the same thing like that on that little on that note card you made us do, which is basically switching into U's, right?
Exactly.
Okay.
So if X is our focus, every other letter is treated as a U.
So you would, like, for everything, would basically, unless you just wanna, like, just do, a chain rule, even.
Correct.
As long as it's not X.
Correct. Yeah, it's basically why we had to do chain rule before we did implicit differentiation.
Yeah.
Okay, well then and clearly there's some other ones on here that they're horrible. I shouldn't say horrible, I mean the answers turn out horrible. They're not horrible to do. Don't feel like you're going to get answers that are going to come out nice and neat. Like number 5, I can tell you, is kind of garbage. And it looks relatively straightforward, but when you do the derivative of cosine of xy, the derivative of cosine of xy is going to be negative sine of xy times the chain rule of xy, which is product rule. And you have to go through a lot of work to solve for y prime at that point. Like trying to get the terms together and factor out y prime makes your answer not good. These are very common questions, so don't necessarily skip this one just because we don't have time. I wanted to get to, I don't know, maybe we should do the tangent line one?
Yeah.
I mean, that's different enough that you guys might feel, yeah, what the heck, let's just do it fast. Why don't you guys try to find the derivative on your own quick of x squared minus xy plus y squared equals 7. Now I say quick in relative terms. And the only reason I'm trying to hurry through all this is because I won't be here tomorrow. Normally I would split this one up over 2 days. Do you want me to zoom in on that? Well, it's all the bigger I get it, I guess. I'm definitely not expecting you to be able to find the derivative that fast. I just wanted to put it all up there pretty quickly so you could see if you made mistakes. First mistake that I know a bunch of people are going to make is forgetting that the minus xy, when you're doing the product rule on xy, the whole product rule is being subtracted, so you're going to have to distribute out a minus sign to both of them. That's the first mistake I'm guessing some of you made. And it's easy to miss that until you have examples with it. From there is possibly forgetting the y prime on 2y.
So do they want the equation line at like x equals -1 and x equals 2?
It definitely should not say x equals -1, 2.
Okay.
It should just say at -1, 2.
Okay.
I didn't notice that either until you.
So it's not two different lines?
No, yeah,
Okay.
yeah. It was. I'm guessing whoever wrote the notes was just in the habit of writing at x equals.
Yeah.
Did anybody bring y prime to the right? Oh, okay. If you do, you certainly can. It's not wrong. If you bring y prime to the right, what you'll find is that the final answer would be completely reversed. You would get 2x minus y over x minus 2y, and it's still correct. Like if I multiplied the top by -1 and I multiplied the bottom by -1, it'd be totally flipped, but still equal. So do know your answer doesn't have to look exactly like this. The only way that your answer will look the same as mine is if you do the steps in the same order, like all the same steps. There's going to be a lot of equivalent versions of the answer. Oh, I thought you guys were still on the derivative. Does anybody want any help on the derivative part?
No.
Like that one? Okay. All right.
Yeah, that should go with,
Okay. Okay, so tangent line, we need point and a slope. Okay. So the slope is what you were figuring out. So y prime at -1, 2. 2 minus 2 times -1. 2 times 2 minus -1. 4? 5? I think I heard somebody say a fraction. Yeah, okay. So 4/5 is the slope. And then your tangent line can be written a bunch of ways. As long as they're equivalent, you're good. I'm always in the habit of writing y minus 2 equals 4/5 x plus 1. But I've been noticing a lot of you have been following kind of the answer key versions, like on the test. And that's, I'm fine with that. On the test, a lot of you wrote the answer like this instead, where you wrote +2 at the end. Definitely still correct. If you really felt like doing a lot of extra work, you could make it slope-intercept form, but definitely don't have to. And honestly, if you got that, that's pretty good. This is a lot of work. Like there's a lot of places you can make mistakes. I'm not going to do B, but have you guys run into the normal line yet? That's what I was wondering. I don't remember seeing the normal line in our packets up to this point. Do you remember normal line from pre-calc? It would have been from vectors. I think it was called the normal something in vectors. It's not the regular line, no. Normal actually has a... This means perpendicular to tangent. Did I butcher that? Perpendicular. So this isn't a problem that we would need to redo. The point would be -1, 2 still, but now the slope we would use would be -5/4. So a normal line means perpendicular instead of tangent. And no, I don't know where the word normal came from, so. Okay, this is what I wanted to get to so that we didn't run out of time. These aren't more difficult, they're just different. You know what? I made the seating chart and I numbered you guys and I totally forgot to start rolling.
Because do it today.
See, both Lukes went yesterday. Tyler went yesterday, I think, right? Yeah, I feel like today should be Ethan's. Because you chose Tyler yesterday. You volunteered him.
Wait, what's our new numbers? Where does it start?
Same spot. I'm not creative. You're 18. You're 18. Okay. Ethan, how do maybe I'll ask this first then. What does that mean? So we had this notation quite a while ago. Okay, so dy dx would stand for derivative. The 2's represent second derivative. So where most people really don't get this is like the squareds in different spots, right? And that's because we're doing the derivative of y, which is where d squared y over dx squared comes from. It's kind of weird, but that's how they label it. So it means second derivative. So find dy dx first, or y prime. So cosine of y equals x. Well, I can do the derivative of the right-hand side pretty easy. So I'm going to take the derivative. So equals 1. Derivative of left-hand side would be negative sine of y times y prime. But I need to solve for y prime. So second derivative means I need to take the derivative of this one, right? Do you guys have any thoughts on how to do the derivative of negative 1 over sine y? I'd prefer to put the negative on top, but it doesn't matter. We could do quotient rule. That is definitely one option. I'm going to guess a lot of you would probably pick quotient rule right away. It's not wrong. I just thought I'd ask. I'm hoping somebody else sees the other option.
The negative 1 power? Not that one.
It's not wrong. I think you're just thinking not in terms of trig. Yeah, I mean, like, you can bring sine to the top as a negative 1 power, but instead of doing that, you could just call it cosecant. Yeah, it's what everything you said so far is correct and would still find the correct answer. I'm guessing any answer keys you look at would write this as negative cosecant. I almost wrote an X out of habit. So I think I'm going to do negative cosecant for derivative. But do know the quotient rule on negative 1 over sine y would be the exact same answer. The exact equivalent answer. It wouldn't look the same. Okay, so the derivative of y prime. What's the derivative of y prime? Feels complicated, but it's not. Y double prime. It feels like it should be like I think I have a feeling you guys are trying to think in your head if there's supposed to be like chain rule or something. It feels complicated. It's not. Okay, derivative of negative cosecant y. Oh, look at all the people bringing out no cards. Oh, that's good and bad. It's good and bad. It's good because you're looking at your note card. Okay, Maddie, what is it?
Isn't positive plus secant, or wait, plus,
Yep.
or times,
All right, wait, let's refresh and start that over.
okay.
But you're correct.
Positive plus secant of y
Why?
times cotangent of y
Yep.
minus y prime, or
Times.
times, I'm sorry.
No, you're good. You're good. I mean, it's easy, but it's not easy. So, and it's positive because we are taking the derivative of a negative one. All right, so here, I'm going to guess a lot of you would circle this.
Round one.
It's not incorrect. It is definitely not what you would ever find as the answer in an answer key, which means it would not be the answer in multiple choice.
Okay.
How should I phrase this? I'll tell you what the answer on the answer key would be, and I'm hoping maybe you guys can figure out where it came from. That would be the answer on answer key.
Like substitute y prime in various times?
Yeah, so it's weird. I mean, I get why it's done. So if you had to plug numbers into your second derivative, when you get to the portion with y prime, you would still have to go back to y prime and figure out that answer to come back. So traditionally, they won't leave y prime in y double prime. So you have to take your answer from y prime and substitute them with each other. So that's why I said the first one I circled is 100% correct. But you're just never going to see it. So the second answer is the one that you would see everywhere. How are we feeling on second derivatives? Is your brain getting fried at this point? Yeah? This is what an 8 I was going to call it 8 a.m. class. 8:30 a.m. class does. You start your day with calc. Sometimes that's good, sometimes that's bad. It's better for your brain. Not saying you like it, but it's better for your brain. Should we just try 9 since we've got a couple minutes? You're basically getting all tomorrow to work, so you don't have any homework tonight or anything. How do we figure out 9? There is a picture next to 9, and you should not be using the picture. The picture is misleading because it's making you think you can just go look at the picture and answer it. Honestly, you can use the picture to get an estimate.
Negative 16.
I'm hoping you got that from the picture already. So vertical line is horizontal lines. Well, I'm going to guess right about there, probably there, probably there. So my guess is this spot, this spot, this spot, and this spot. But we're definitely not allowed to use the picture to get that. Anybody have any thoughts on how we figure it out with no picture? I'm hoping this is because nobody wants to speak up because it's so early.
Wait, are you asking if we would have been able to do that without the picture?
Oh no, we're definitely doing it without the picture.
Oh.
The picture is just there to
So what
back
was
you
the
up.
question again?
How do we find the answer?
No, well, wait.
It's written down.
Oh, you're asking that you like,
How do we do it? Like, what should we do?
oh, I know what you're asking. Sorry.
Well, I'm asking you what the question
Oh,
asks.
okay, I thought you were. Yeah, my bad.
Pull your eyes. I think the class is hoping to be bailed out.
Is that y prime equal to 0 for a vertical line?
Backwards. What you said was good, but what you were saying was for a horizontal line. So we need to find the derivative because that tells us slopes. So even before you actually get to the figuring out part, you have to find the derivative. So we're given an implicit equation where you have to find y prime. That's your first step. And that's pretty much the big step. So try to do that part on your own. Wait, what time did we get out? 28?
Yeah.
Ooh, let me hurry. I just said 28. 2x plus xy prime plus y times 1 plus 2y y prime equals 0. And I need to solve for y prime. I'm hoping you guys will be good enough to start doing these steps in your head, but I don't know. I mean, like, it'll take a little practice. So y prime is going to be negative y minus 2x divided by 2y minus, no, x plus 2y. Now, rather than killing you off, since we only have a couple minutes left, let's use the picture in conjunction with our derivative. So I believe, what is that one? Negative 3/6. So my one guess was negative 3/6. If I plug that in, I should get an answer of 0. Okay, so negative 6 minus 2 times negative 3 over negative 3 plus 2 times 6 is 0 over 9. That tells me it's horizontal. What should the vertical lines look like when I plug the numbers in? Divided by 0, right. Good. So let's try one of these vertical ones and test it. That's probably all the time we'll have. Negative 6, 3. So then we will do negative 3 minus 2 times negative 6, which is a big number, over negative 6 plus 2 times 3. What is this? 12 minus 3, 9 over 0. Yeah.
So if we were given a graph, like how do we know which like points to try?
I'm not going to fit that one in 3 minutes. Just know that for now you won't.
Okay.
This is more of a challenge question. If I were to ask you this question, I guess I would probably give you just similar to this, yeah.